In part 2, we have two possible values for z. Okay, but now in part 3, it is given to me that c is less than 0, and c actually represents the real part of the imaginary portion over here. So this is the z that we want, because c here is negative square root of 3. Okay, so this is the z that we want. So for part 3, z is 1 minus I square root of 3. What we want to do now is to find the smallest possible value of n such that modulus of z to the power of n is bigger than 1000. If you want to find modulus of z to the power of n, or rather, we want to look at the complex number to the power, okay, which means that what I can actually apply, it is the De Moivre's theorem. And to apply the De Moivre's theorem, we need to re-express the complex number in the Euler form or the trigonometric form. Okay, so from here, I want to find what is the modulus of z. Modulus of z is square root of 1 square plus minus square root of 3 square. It is square root of 4, so this is 2. And I want to find what is the argument of this. I'm going to sketch it on an Argand diagram. Okay, this is the argument, and z is 1 and minus square root of 3. So this argument here, this angle here, which is argument of z, it is going to be negative tangent inverse of square root of 3 over 1. Okay, so this is going to be equal to negative pi over 3, which means that z can be re-expressed as 2e to the power of minus I pi over 3. And the question says that modulus of z to the power of n, this is going to be bigger than 1000. Modulus of z to the power of n is the same as modulus of z to the power of n. This is bigger than 1000, and modulus of z is 2. So it is 2 to the power of n. This is more than 1000. And for what we have here, I'm going to try to ln both sides. So it will be n ln of 2 is bigger than ln of 1000. So n is going to be bigger than 9.9658. Okay, so the smallest positive integer for n, the smallest positive integer for n, it is going to be equal to 10. And the next part of this question is, with this n that we have found, n is equal to 10, I want to state the modulus and argument of z to the power of n. So modulus of z to the power of n is going to be 2 to the power of n, which is when n is equal to 10, it is 2 to the power of 10. And 2 to the power of 10, this is equal to 1024. And when n is equal to 10, the argument of z to the power of n is the same as the argument of z to the power of 10. It is 10 times the argument of z, which is 10 times the argument of minus pi over 3. And this is going to be equal to minus 10 pi over 3. It exceeds the minus pi and pi range of a typical argument of a complex number. So this I'm going to add 2 pi and add 2 pi. Okay, so I'm going to add 2 pi, and I can still add one more 2 pi, and this will bring me bring the argument back to a range that is between minus pi, and that will be 2 pi over 3.